So thanks for coming to Enterprise ENT210, our data transfer services session. My name is Mark Trimmershot. I run the technical business development team for storage. So that's across all of our storage services, and we'll talk a little bit about what those are, but it ranges from our EFS, EBS, our object storage, including S3 and Glacier, all the way through ingest. And so this session, so that you know you're in the right one, is how to get large amounts of data into AWS so that you can take advantage of all the different services that we have to offer. So we're going to go through the range of service offerings that we've had, go through some customer use cases today, and then also talk a little bit, do a little deeper dive on some of the new services and enhancements to existing services that we announced just this week. And again, to keep it kind of fun and interactive, I'm going to be handing out a couple of prizes along the way as we'll put some spot quizzes in the presentation. And so hopefully you'll be paying attention and I won't put you to sleep, and you'll get something out of this session today. And please, at the end, if you do or don't, and hopefully you will get something out of the session today, please fill out your form and rate the presentation. We're always interested in feedback. So when we think about storage at AWS, and I think you saw Andy's presentation this morning, we think of storage as really the foundation and entry into all the different services that we offer at AWS. Because once you have data in AWS, then you can take advantage of elastic compute, all the different range of 70+ services that we offer in our portfolio today. And so storage, I think about storage as really having 4 legs of the stool, table, couch, whatever has 4 legs, unless you're sitting on a 3-legged chair. But there are really 4 areas that we think about in terms of storage. So for those of you that come out of traditional enterprise storage like I do, we have the equivalent of enterprise storage. So EBS is our block storage. So you think about traditional SAN or local attached storage. That's our elastic block store. And then also we introduced earlier this year EFS, which is our managed elastic file. That's NFS v4, v4.1, fully managed, very scalable, on-demand elastic file system that's offered. And again, those are kind of the equivalents for customers that are moving and beginning their journey into AWS. EFS and EBS represent great kind of entry points because it's really easy to lift and shift workloads to take advantage of what they've been doing already, which is taking advantage of SAN and NAS in their environments, and then moving that into AWS. When you think about really kind of the scalable internet storage solutions and think about taking advantage of AWS and the cloud, though, you're really starting to think about our object storage. So that's the 3rd leg of the stool. So we have Amazon S3. We have a middle tier of anybody know what the middle tier is called? That's one of them. There's another one. There's a middle tier between S3 and S3IA. Or I said it, so yeah, S3IA. S3 and S3 infrequent access for less frequently accessed data. I'll give myself a hat. Hang on. I don't look good in hats. Just my ears and my head's too small. So I hope we'll pass around. We'll make it up in a minute. But there's S3 infrequent access for less frequently accessed data. And then we have, obviously, Glacier. We've made some really interesting announcements over the last week with Glacier. So Glacier now has, Glacier is our tape alternative for archive. So the idea is if you currently have an on-prem LTO tape library shipping off tapes to Iron Mountain, or have an on-prem library that you want to perhaps have a cloud equivalent for, we introduced Glacier a few years ago in 2012, and the access time for that was 3 to 5 hours to be able to get your data back. And what we did last week, I don't know if you caught it, but we introduced 2 things. One, we reduced cost on Glacier. We reduced it from 0.7 of a cent to 0.4 of a cent for major public regions. And then secondly, the cool thing is we introduced 2 new retrieval options for Glacier. So those 2 new options allowed a fast, or what we call expedited retrieval tier. And that allowed customers now, like yourselves, to be able to access Glacier data in 1 to 5 minutes rather than waiting 3 to 5 hours. And for that, we charge a little bit more, to access the data. So that's 3 cents per gig versus the 1 cent per gig for the standard Glacier. And then at the opposite end, we also introduced a bulk retrieval tier. And so customers who have big data applications, I work a lot with media customers, and a lot of the examples here that we'll talk about today are moving large media files or large amounts of data. So I think this next tier, the bulk retrieval tier, is super interesting to a lot of customers because that allows customers now for about an 8 to 12 hour SLA to retrieve large amounts of data, petabytes, be able to say perform transcode an entire library, and we're only going to charge a quarter of a penny for that retrieval versus a penny per gig. So we've really expanded the options for Glacier for that archive use case, and that's opening up a whole host of new opportunities for our customers. So the area in the fourth leg of the stool I want to spend the rest of the time, the rest of the presentation on today, is the ingest leg, if you will. So we have a number of new announcements and a number of existing services, and I want to go through each one of those services to help you understand what your options are to get data into AWS and then make use of these different storage tiers and different range of services that we have. So the first is over the internet. So obviously, having a solution like S3 and all of our solutions, you want to be able to take advantage of being able to just access over the internet versus other solutions. So the obvious thing is getting data in over the internet and an internet VPN link. So it's globally available. It's the default method for ingesting content into S3. You have a really simple connection. It's available in a VPC, and data transfer in, and I think this is something that's maybe not known to a lot of folks, is getting data into AWS is always free. So there are egress when you take data out. There are egress charges for bandwidth, but when you put data into AWS, there is not a data transfer fee. So Internet VPN ingest works very, very straightforward. You can ingest data directly in S3 buckets. And then one of the tricks that we'll share is one of the things we talk to customers about is how do you move, again, this session is all about moving large amounts of data. So particularly when you have large files, and for those customers that have maybe smaller files, we recommend maybe aggregating those smaller files into larger files. There's something called multi-part upload. So when we hear customers trying to upload large amounts of data, one of the things that we always talk about in terms of a best practice is use S3 multi-part upload. And this in particular is good for anything over a couple megabytes in size, where you're able to basically take advantage of parallelism. So S3, by definition, by its nature, is a massively parallel system that allows basically multiple streams to be able to be fed into the object store simultaneously. Well, you also have, if you back off and come from where you're coming from on-prem, you also have constraints of getting data in as far as internet links. So something that allows you to take maximum advantage and fill your entire internet link, as well as take advantage of the parallelism of S3, is multi-part upload. And the way that that works is under the covers, you basically specify there's a multi-part upload option when you put an input request, and it breaks that file up that you're trying to upload into many pieces and then parallelizes that upload. So that allows you, A, to fill the pipe, especially if you're going over longer latency links. What tends to happen is even if you have a gigabit link, but if you're trying to, say, drive that over, for those of you that are used to, say, running, say, one side of the country to the other, or especially over international links, if you're trying to, say, move a file from the U.S. To a region in Europe, what will happen is the constraint isn't the internet link speed, but rather it's you can't fill the link itself because it's due to latency, due to underlying TCP properties. So for those of you that are familiar with networking issues, you'll understand exactly what I mean. So multi-part upload allows you to essentially fill that pipe along the way. because you're essentially opening up multiple flows and multiple connections simultaneously. And then once it arrives in S3, it allows you to take advantage of the parallelism of S3. So you're kind of, if you will, taking advantage of parallelism all the way through from the point where you're uploading all the way through and into S3. So just a little tip in terms of getting lots of data up very quickly, even using standard internet links. We had a customer, they were uploading 20 petabytes of data. They did a large migration, and they used a combination of snowballs, but then the rest of the data was actually uploaded over the internet using multi-part upload. So also dealing with latency and long distance, how many of you have a use case where you're trying to upload files from many locations around the world into one region? Okay, you get a snowball magnet. Hang on, look. Okay. It's soft, so. I was at a show in New York. Somebody threw a hammer out at the audience and said "catch" last week, and it was a rubber hammer, but it scared the crap out of me. So I'm careful when I throw things now. But so one of the things, so for your use case, we created something called S3 transfer acceleration. So the idea is normally you have an endpoint and you upload over the internet. And what happens is you have latency, all the things that I talked about, the vagaries of the internet. One day it works, 1 hour it works, 1 minute it works, and then you have a storm, and all of a sudden your internet, basically you're going to get inconsistent performance. So what S3 transfer acceleration does very simply is we use our Route 53 DNS lookup service and find the closest of the 59 global edge locations that we have, and takes a look and says, you're in Europe. And instead of moving and transferring the data out over the internet, what we do is we establish a connection with the local POP, and then hop onto our backbone and transfer that then in a consistent, high-performance way back to the S3 bucket, in this case, that's in a region, say, across the world. And so we use, actually, under the covers, CloudFront. How many of you have heard of CloudFront or CDN? Okay, so we use CloudFront's backbone. So same backbone, but we don't cache at the edge. So in terms of caching, if you think about a CDN and coming out, we're not caching the data at the edge, but we are using that backbone, if you will, to provide a high-quality, consistent experience to move large files. So use cases for this in particular are like large media files and other files that are uploaded on a regular basis from many distributed points around the world. And so how fast is it? We'll jump to this and then jump back. So the net of it, for your takeaway, the rule of thumb is, if you're in the same region and you're trying to transfer, say, from in the US East to some region in US East, it's not going to help that much. But if you're trying to transfer from another part of the world, say from Singapore or from Sao Paulo back to the US, again, the higher the latency, the bigger the benefit. And the best way to find out is try it yourself. The business model is it's either faster or it's free. So there's really no benefit, no drawback to trying S3 transfer acceleration. And in many cases, again, where you're trying to have many to one from many locations into one region, it's a great option for you and something that we launched earlier this year. So a few good examples. One I'll pull out in particular is a company called Huddle. They do coaching videos. So from professional sports leagues all the way to Little League, coaches upload their videos into, and then they're processed and then can be shared for analysis later into Huddle's, which is powered by AWS. And so what Huddle was able to do is, from all these different locations around the world, be able to take the data, take these videos, and accelerate then their onboarding into AWS. So that's S3 transfer acceleration. I'm going to talk about Direct Connect. So transfer acceleration, we've gone through a couple options. Internet is great, it's flexible, it's easy. We talked about S3 transfer acceleration, which is from many to one. But what if you're a customer today, and many of you I know, because this is an enterprise track, are enterprise customers that still have, say, some workloads on-prem, and some workloads in the cloud. If you are in that case, you might want to take a look at Direct Connect, and I'm sure many of you, how many of you have already provisioned a Direct Connect? Okay, quite a few, and I'm sure as you come on board, there might be additional use cases and additional folks that are going to be provisioning Direct Connect. Direct Connect is great. It's offered in a number of different configurations, but basically it's exactly what the name is, which is a direct connection from your location to, or in a cross connect to an AWS. Into AWS. It's a dedicated 1 or 10 gig private link. You basically, the benefit is you can get that consistent performance, number one. And number two, when you are looking at costs, if you will, especially if you're not distributing, if you're not a consumer-facing company and you're simply looking at getting data back and forth between your on-premise location, say, or several on-premise locations and AWS services, well, then if you establish a direct connect, the egress bandwidth price is significantly lower than just using an internet connection. So again, it depends on if you have a lot of internet-facing, consumer-focused applications, then probably a direct connect may or may not make sense for you. But if you're moving data back and forth between, say, corporate locations or workloads that require a lot of data movement between point A and point B, and it's point to point, then it makes a lot of sense. So it's a cross connect at your location, most likely within a colo. So we're at Equinix and similar locations around the world. And it's basically offered through a range of direct connect partners that we have around the world. At the location, you can see it's really straightforward at the direct connect location. You can plug it in as a cross connect, either 1 or 10 gig, or you can have a dedicated port through a direct connect partner. So one thing, and this is not really a direct connect feature, but I wanted to put it in here, is we're offering EFS through Direct Connect. So this is something that we're going to be expanding the ability to do a hybrid network by offering EFS directly over Direct Connect as well. So we've talked about connectivity. Let's move it up a little bit and talk about integrating for hybrid networks for on-premise workloads where you just can't write natively to S3 or S3 interfaces, right? So we have something, how many of you have heard of Storage Gateway or using Storage Gateway? Okay, I don't have that many hats, so I'll just say thank you. But I'll ask some harder questions in a little bit. But Storage Gateway is designed, it's typically an on-premise virtual instance that is VMware, Hyper-V. We also offer our own AMI version of the existing Storage Gateway. And the idea behind Storage Gateway is that applications like backup, which require maybe a VTL target, or traditional applications that can't be re-architected or that are on-prem, that can't be re-architected to use, say, the S3 native interface and just want to write to a POSIX-compliant file system or to a VTL target like a backup. They then can benefit from Storage Gateway. You set up an instance. You basically point, say, your HP data protector at the VTL target, and it just looks like a tape device. So, and then behind the scenes, what Storage Gateway does is translate that to HTTP, so RESTful interface, and then puts that data into an S3 bucket. And up until this week, that was stored in what's called a private bucket, meaning you got the advantage of being able to take advantage of cloud storage, but it wasn't accessible in S3 in your own bucket. So what we've done is opened up that use case to something that we call File Gateway. So we've added, I talked about the two modes that we had before, which are iSCSI and also Tape Gateway, which is VTL for those backup use cases. And we've added this really, and this is, I think, personally, one of the most exciting announcements for me coming out of the traditional enterprise world and coming into AWS, because this File Gateway opens up now a whole host of additional applications and opportunities for customers, applications who are not natively written to that RESTful interface. And let me be specific. File Gateway is a new capability that provides an NFS mount point now, version 3 and version 4.1, and this is available as a VMware image initially. It gets installed on-site, on-prem, and then provides an NFS mount point for your applications to write to it. So that in itself is cool, is native NFS capability, because a lot of applications, we're working with a number of customers, say in genome research or lab equipment, or they're just, those applications aren't ever going to change to anything other than writing to a POSIX compliant file system. The other thing I hear from customers is certainly they could re-architect their application to write to S3 directly, but they have 100 other priorities other than re-architecting their application to write to S3 for that particular application. It's just not a priority. So what file gateway, the file mode now brings out is the ability to write to a local NFS mount point, number one. And number two, take that and then transparently write that to a customer's S3 bucket. And so what does that really mean? Well, it allows this transparent mode to be able to write, say you have, so we have a great customer, they have lab equipment, they're writing text files, they're writing, so in media, another customer is writing media files like an MPEG file. It will write that file into the local NFS mount point, translate that, and basically it'll end up and show up in a customer's S3 bucket. Then, for example, with our media customers, they can kick off a Lambda function and kick off a transcode. Or some of our big data customers now can take that data and incorporate it in their data lake to kick off an EMR job, for example. So the key difference in the new capability that we're introducing, that we've introduced this week, is now that transparent capability to be able to do a one-to-one file mapping of your file to object in your S3 bucket. And so if you look out either our old gateway or any other third-party solutions out there, what they typically do is they'll present an NFS mount point, but they will then, if you look at under the covers on S3, you'll just see basically aggregated blobs of data in an object, but you're not going to be able to do anything with that object unless you pull it back out via the same gateway. So what this new file gateway interface allows you to do is basically take advantage, manipulate that data in its native form, and then open the world of AWS services. The second thing it allows you to do is migrate, right? So all the other solutions out there, ours included, are great if you want to use essentially S3 as a tiering option for lower cost storage. But if you are in the process of migrating your workloads and migrating to the cloud, they really don't help you there because you have to pull the data back out again, and then you'd have to migrate it up a different way. So with File Gateway, it offers both, right? You can move the data and migrate the data, and then if you want to cut the cord at some time, you can as well. So two customers that are using us today, they're two examples, and we can dive a little bit deeper, are Moderna. They're a great customer that's using us for, they're the lab equipment customer that I was talking about. So they have lab equipment with firmware that can write to a POSIX file system and really can't change that. So now they have the ability to write to a local NFS mount point and then manipulate and take advantage of the workflows and elastic compute that we have in the cloud. A second customer of ours and partner is Veristore, and they're using us to offer, they're using this in a variety of ways to offer file gateway services into AWS. And there's a specific session I encourage you to go to that's only on Gateway called STG213 for a deeper dive on this as well. You can tell I'm excited about it because it's opening up, I think, a world of possibilities for workloads for everybody in this room. So, Snowball. Okay, here's the trick. So what's the new capacity for Snowball that we just introduced? Okay, you were kind of the first one, just probably because you're the closest and I can't hear that well. So you're lucky. So kind of like those shows where you go and you got to wear the raincoat in the front. So it's kind of like that. You're lucky. In this case, it's the opposite, I guess. So you get a magnet. So with Snowball, when we introduced Snowball, the design center was for batch uploads, right? So for customers that are trying to migrate their data in mass. So we've had customers, I've personally worked with customers that have moved 10, one customer that just finished up a 20 petabyte migration from on-prem, from a range of on-prem arrays and tape libraries into S3 using Snowball. So the original design point was 50 terabytes when we introduced it. We upped it earlier this year to 80 terabytes. It is an integrated e-shipping label. So we had one customer, they said, well, they wanted to put on a shipping label on the outside and stick that. And we said, no, well, Snowball does that automatically. And so it's really, from a workflow perspective, we'll go through that in a minute, but basically when you power it off after your job is done, it puts a return shipping label automatically using an e-ink display, also known as a Kindle, that allows it to automatically ship back for processing. So it's rust and it's rust. It's rain and dust. I guess that's rain and dust together. I don't know that it's rust resistant, but it's rain and dust resistant. It's tamper resistant, and probably most importantly is all data is encrypted end to end. So really, with Snowball, we've introduced some additional capabilities. So we introduced the 80 terabyte model earlier this year. We introduced new APIs. So some of the cool new capabilities are for those of you that are big data customers that are, say, Hadoop or HDFS users. We introduced a native HDFS capability. We also opened it up to third parties. So back in August, we announced that Commvault and others had integrated, and we're constantly announcing others for this third-party API. And then we're announcing HIPAA support as well for Snowball. So for healthcare use cases, obviously, that's critical. The other thing that we announced and committed to at the beginning of this year was that we would make Snowball available in additional regions throughout 2016. So now Snowball is available in all regions around the world except for the ones shown, which is Singapore, Seoul, and Beijing. So Snowball, the best thing is it's super simple. Snowball, you basically go into your console, you order it, it shows up. You copy over the files. You basically you have a number of different options now available, but typically customers have a client that runs on a server. They copy over their files. They have their own, so you can use your own keys. They're encrypted from the time that it leaves all the way into the Snowball through transport of the Snowball. Then, as I said, you power it down when your job is completed. It doesn't automatically ship. That would be super cool if it actually walked out by itself, but it does everything but that. It puts on an e-ink display with the return shipping label. It ships back, and within a few days, however long it takes to ship back, plus ingest time, then it will appear in your bucket. So a little bit of a comparison, and this is before the 100 terabyte release, but to kind of give you an idea of comparison, again, for these batch moves, of how many days it takes to move data before and after Snowball. So if you're looking at, and any one of us, are you really, if you have a 1 gig or a 500 megabit per second link, let's just take a 1 gig link, typically you're not going to dedicate that entire link to transferring your data. We had a conversation with a customer yesterday, and he said his wife was uploading all the images, a terabyte of data, and it took down their entire home network. Nothing else was working. They couldn't, there was no access to internet, there's no access to cable, there was no access to any of the services that we've come to depend on. So you don't want to take up the entire 1 gig capacity. Typically, you don't want to do that to your business either. So depending on whether you could say you're going to dedicate 25, 50%, or 70% or 75% of the utilization, you can see the amount of days that it takes to ship the comparable amount of data of 200 terabytes over the 1 gig link. So for example, assuming you want to dedicate half your bandwidth, which is a lot, it's still going to take you about 36 days to move that data. Assuming, again, back to the point earlier, that it's a fairly low latency connection, because then, again, with high latency, all these numbers could double, triple, or quadruple. So again, Snowball, in a prior life, I worked at a LAN optimization company, and Snowball is this really cool, unique solution that AWS has come out with, listening to our customers, trying to move data over the wire by eliminating essentially the WAN link, by getting around the WAN link, the next generation of sneakernet, if you will, with Snowball. So Scripps is a great example who used Snowball for a large migration. So a lot of media customers use us. So massively scalable ingestion, petabyte scale support, and what Scripps used us for was moving a number of media files from their on-prem archive into AWS. So we started there. We talked about Snowball as a transfer vehicle. What we've done with Snowball, and we're calling it Snowball Edge, and that's one of the the magnets here. We've kind of smushed it down and stretched it out a little bit in terms of form factor, but we've increased it to 100 terabytes of capacity. We have also added some new capabilities and some new integration points. We talked to customers, and customers were asking for additional interface points other than having just the existing Snowball client. So what we've done is we've added NFS capability natively to it. And then we've also added, for those customers that want to write to an S3 endpoint, I think you saw Andy's presentation this morning, we provided that capability as well. So any application that can write to S3 can do it. The big thing that we've done is also add the ability to run some compute functions on board. So essentially we provided, you heard Greengrass earlier, so we provided Greengrass support on Snowball, and that allows us the ability then to run Lambda functions. So now you can think the evolution of Snowball is not only as a transfer vehicle, but it's also the ability, as if you think about kind of the different applications and use cases, you have a collection, and you might want to do processing independent or prior to uploading into the cloud. So the kinds of use cases you can think about now with the new version of Snowball Edge are offline staging. So we work with a number of companies that are in the oil and gas industry where they're on oil rigs, or you're out on a ship somewhere and you don't have really good connectivity, but maybe you want to do local processing. You have different IoT applications. Andy talked about some of our partners that have windmills or other alternative, just far out, really bad connectivity where they want to collect and process, but they don't necessarily have the internet connectivity or any internet connectivity until they ship back the device. Local tiering and compute. So this is an emerging area where if you thought about Snowball simply as a transfer vehicle, now we have the ability to actually, and again with the clustered mode of Snowball, the ability to do some very interesting compute and processing functions. And then local transformation. So a good example of this, and we're going to be highlighting this in another session, which is a deep dive on STG214. So Philips is using this. So in hospital environments where you have a higher resolution, say DICOM image, X-ray image, and you want to transform that and have, say, a lower res image created along with extraction of metadata. So all of that now can be done semi-autonomously and processed prior to shipping back the larger images into AWS. And if it's not big enough, we have Snowmobile. So what's the what'd you say? What's the design capacity for Snowmobile? I heard a couple over there again. There. Okay, you guys be honest. I don't remember where it was, but I heard the mumbling over here. So, okay. Great. And what's the length? 45 feet. Who's the loudest? That was, I think it was it you in the green? Okay, great. Here we go. I'm getting, that's awesome, good. It's not a hammer, it's light, it flies, so. Yeah, so we're pretty excited. Not everybody's going to take advantage of Snowmobile, but it really shows the capabilities, and honestly, if you're looking at 100 petabytes, that's obviously perhaps on the high end for many customers, and it's actually not on the high end. We have customers that are looking at moving exabytes into AWS, but really if you're looking at any kind of double-digit tens of petabytes, rather than having number of snowballs, and actually can take snowballs and run them in parallel. So that's what customers have been doing today. But by the time you hit maybe 10, 15, 20 petabytes, that's really where you might want to think about having a Snowmobile. And so that is available now. And please, if you have an opportunity, we'd love to talk to you about it. So we've talked about some of the native capabilities with AWS. And we've talked about some of our own solutions as far as one-time solutions, as far as batch mode, as far as ongoing with Direct Connect. But we also have a range of storage ecosystem partners that we've partnered with. So the use cases that we try to segment some of our third-party partners into are backup. So this is one of the big use cases if you talk to CIOs one of the top use cases for cloud that we hear is disaster recovery and backup. So over the last year, we've really worked very closely with a number of the traditional enterprise backup and data protection vendors to provide very tight integration to make AWS a great backup and disaster recovery target. So you can see some of the backup vendors that are available direct or through our AWS storage VTL mode. So the way that that works, you have a backup vendor. You're normally targeting an on-site tape library or a tape library alternative that supports a VTL, and essentially we look like a tape library. So the vendors that you see listed support AWS through that mode. We have another set of customers or partners that have taken the additional step of integrating natively with AWS. So, for example, those customers of that are, say, Commvault or Veritas or Legato Networker, now EMC Networker, we have now the ability to have direct integration with those products. So we have a number of customers where they're simply backing up today to on-prem, and now they can take advantage and simply literally point the fire hose, so to speak, at AWS S3 as a target. I'll point out Commvault has taken the additional step, and a number of others will in the future, to be able to take advantage not only of S3 as a target, but then also be able to kind of tier and use the AWS S3 lifecycle management to lifecycle down to Glacier. What that allows customers to do then is take advantage of the different tiers and the cost efficiencies of the tiers where you don't need the data, say, very quickly, and you want to basically have it by definition when, in the case of a disaster, or when you want to restore it and when there's a data loss, but you don't want to pay to have that data hot. You can tier that through the solution offered by Commvault and others. So that's kind of the backup use case. A second use case for hybrid is file systems. So I think we talked about our own gateway, so that's definitely a good use case where you can have a little bit of hot cache data and then have those objects appear in S3 natively. But a lot of customers have other use cases. So one of the big use cases we hear from customers is, I really want to have some high performance NAS still on-prem, but then be able to take advantage of the cloud for essentially this overflow pool of storage for cost efficiencies, for other reasons. So we have a number of solutions from NetApp, from a company called Avere, from Cetera, that allow you to do that use case or have that use case, which is a one site, if you will, and tiering that out to the cloud. So NetApp actually has two or three different options. They have a product called AltaVault that is more of a backup use case. They also have the ability to synchronize essentially an rsync kind of capability in their ONTAP operating system, and we're collaborating with them even more on some future solutions where they'll be able to extend and tier in their capabilities into the cloud. If you have a solution where you have multiple sites, so how many of you have a use case where you have, say, multiple sites that want to be able to access locally via SIFS interface and then be able to have the back end in the cloud? Okay, so you get the Snowball magnet. You already got one? Okay, who else has one? Okay, this gentleman on the end. You got it? That one's a little heavier, watch out. Okay, so good, didn't poke an eye out. So we have solutions like Panzura, and Nasuni and others that offer this kind of distributed file system capability where you then have an office, say 20 offices around the world. It presents a local file system, local SIFS interface, but it's back-ended by AWS. So that's kind of a second use case. Object storage, so being able to have this hybrid object storage use case is interesting for customers who want to have a little bit on-prem and a little bit in the cloud. So we have partners in that. And then block storage options as well from VMware and others. So kind of to walk through a couple of the use cases, because again, I think if you looked a few years ago, the only way to get data into AWS for a backup use case was via our VTL gateway solution. Now, over the last year, we have virtually all the backup vendors, all the data protection vendors have native integrations. So you're going to think about those are the two real use cases that backup vendors and data protection vendors offer for integration. You can either have, again, a native cloud connector, or you can use one of these cloud gateways, either our own or a third party. So again, I think from a use case perspective about getting data into AWS, there are now a number of different solutions to support all of these traditional on-site data protection mechanisms and vendors, and many offer direct. For those that don't offer direct, we offer then the ability to support that via our gateway or via a third-party gateway. So to kind of summarize the different solutions that we have that offer that our customers are looking for in terms of moving and migrating data, either one time or many times into the cloud. First of all, for migration, bursting, say, for bursting capacity or tiering, our own storage gateway that we've introduced with the new capabilities for NFS provides a great capability for that. If you want simply to have migration and bursting capability, we offer this extension of EFS via Direct Connect. And again, that allows you to mount an NFS mount point on-prem via our Direct Connect. So if you have a Direct Connect today, you'll see an NFS mount point and put data into EFS. It's not really a tiering. Yep, go ahead. Excuse me? Today it's NFS, NFS v4 and v4.1, but Windows support, SMB support is on the roadmap. Good question. Hang on. Let's see, do I have a... you want a trucker hat? Okay, I think I got one more magnet. There we go. Snowball Edge is great for all three use cases, and then if we don't have the solution, we're going to offer it via a third party. And again, with AWS, what we want to do is provide it's not a one-size, we get it, it's not a one-size-fits-all solution for everybody. You all have different requirements in terms of moving data, whether it's one-time, whether it's bursting, whether it's tiering. So if you think about the different use cases, you'll likely map to one of these use cases. So other sessions that you want to think about for related sessions, we have Deep Dive on Snowball Edge. We have STG 214 and Enterprise 211 for the enterprise track. Snowmobile, STG 214 and Enterprise 211 as well. And then Storage Gateway, especially, I think will be very interesting, as 213 and Enterprise 211. And so with that, I'm going to leave about 10 minutes or so for Q&A.